So he goes to Oak Ridge, and Wigner said, Alvin, you got to go there because you got to go see if you can make this thorium work. It's that important. And Alvin got it. Here was a quote from his book. He said, until then, I had never quite appreciated the full significance of the breeder. And when he's talking about breeder, he actually means the thorium reactor. But now I became obsessed with the idea that humanity's whole future depended on the breeder. The idea that if you don't go and access the energies of thorium, we're not going to make it. So they began working on this high temperature reactor, and here was their notion.
Proved to them that essentially their notion was correct, that you could sustain nuclear fission reactions inside a salt, that it would operate at high temperature and low pressure, that it was very stable. And the reason why it was so stable was as the salt would heat up, there would be less fissile material in the nuclear reactor core, and so fission became less likely. Conversely, as the salt cooled down, there was more material because the salt was contracting, and fission became more likely.
You engineers out there, that's a dynamically stable system.
Gets hotter, cools down, gets too cool, heats up. And Weinberg petitioned the Atomic Energy Commission in the United States for money, and he got a little bit. He got enough to build a demonstration reactor. It was supposed to be less than 10 megawatts, and they built it. It was called the Molten Salt Reactor Experiment. It ran from 1965 to 1969.
It turned out that thorium was a great fit in this reactor. This is what's called a two-fluid molten salt reactor design.
What is molten salt reactor in relation to lifter and vice versa?
Lifter is a molten salt reactor. All lifters are molten salt reactors, but not all molten salt reactors are lifters.
You've got this core fluid, a lithium beryllium salt with uranium tetrafluoride in there. Now what you want to do is you want to move that fuel you've made from the blanket into the core. And here's how you do it. You take a stream of this blanket salt off and you put it in this fluoride volatility column. You hit the salt with fluorine gas, and what will happen is uranium has two kinds of fluorine states it'll be in. There's uranium tetrafluoride, 4 fluoride ions, and then there's uranium hexafluoride, 6 fluoride ions. Uranium hexafluoride is a gas, uranium tetrafluoride is in solution. If you hit it with fluorine, it will start to bubble out of the salt, just like bubbles in your pop. And that's great because this is a neat trick. This is a way to get your uranium product to come out of the blanket and leave everything behind. This wouldn't work if thorium also had this same trick. If thorium would turn into a hexafluoride and a gas, we'd be up the creek. This is one of these little miracles of nature. So you can sit there and pound thorium with fluorine all you want. It's not going to change. It's going to stay in solution. But the uranium will come out as uranium hexafluoride, a gas. Well, now you need to move it into the core salt. So you bring a stream of core salt over here, and you introduce this uranium hexafluoride here, and now you hit it with a little hydrogen gas. The hydrogen will say to UF6, hey man, I want those 2 fluorines a whole lot worse than you do. UF6 gets stuck up at the gas station, has to give up 2 fluorines, and drops from UF6 back to UF4. Whoop, it's in solution now. So now you've just refueled your core salt with uranium tetrafluoride. So cool trick, huh? You're continuously refueling your reactor all the time. You're always refueling the core with new uranium-233, and uranium-233 is being consumed, but the neutrons from the fission are making new uranium-233. Okay, well out of the top of this column comes hydrofluoric acid, HF. You send that down to this electrolyzer unit, and you hit it with some electricity, and the HF will split into hydrogen gas and fluorine gas. And guess what? Now you've regenerated your 2 reactants. So your fluorine and your hydrogen are ready for duty again to make this trick work. I mean, this is a piece you can actually buy off the shelf. So this is pretty cool. This is a closed cycle for how to get your new fuel from here into here. You're essentially converting thorium into energy. First into U-233 and then into energy through fission. Now, of course, you're using up some thorium doing this, so you need to have a little feed of thorium fluoride. You need to feed some new thorium into the blanket to make up for the thorium that you're consuming. But very, very efficient reaction.